Before your team can take defensive actions in a hazmat incident, NFPA 472 requires that a thorough plan be formulated. Limiting exposures, clearly defining your incident objectives, and determining your defensive options are critical steps in this process. To help you understand each of these steps, you will learn how to limit exposures using available resources, determine defensive objectives, assess risk to responders, identify defensive options, and choose the appropriate control techniques. When you work the scene of a hazmat incident, one of your primary goals should be to limit exposures. Knowing what your available resources are and how to maximize them will help you achieve this objective. If you are dealing with a very small amount of a known material, such as a fuel spill, you may be able to take offensive measures to quickly control or contain the materials. But when releases are larger and can affect many people, you are required to create a plan to control the scene. First, identify roads or access points that present the most traffic using maps or your knowledge of the area.
Enforcement for traffic.
If possible, call law enforcement to create roadblocks or deny access to the scene. You should also use predetermined contact numbers to inform other agencies, such as the EPA, included in your local response plan. Next, determine if any members of your team will need to be deployed for scene control. Then, plan for a responder to try to locate personnel from the company that carries or stores the materials. Many facilities have chemists or toxicologists on scene that can be of assistance. Next, assign a team member to use an air monitor. This will help you maintain knowledge of air quality to ensure scene safety throughout the operation. Now, you will need to develop a contingency plan for evacuating the area or calling for the public to shelter in place. This includes predetermining evacuation routes and how you will involve law enforcement in this task. In addition to evacuation plans, you need to be ready for any rescue procedures. Be prepared to use rope rescue equipment, extrication gear, and trench rescue tools, among others. Determine who will be using this equipment, what types of tools are available, and how it will affect the time it takes to remove subjects. You may also need to contact a technician-level rescue team for assistance. The next plans you need to formulate have to do with decontamination. As a first arriving unit, try to locate an upwind or uphill location that will likely be outside of the hot zone. Once technician-level teams arrive, they will make a final determination about where the decontamination areas will be placed, who will set them up, and how medical units will access patients. Plan for how the runoff from decontamination will be contained, how it will be controlled, and who will be assigned to the task. Then plan for any defensive actions you may need to take. This includes assigning team members and locating and organizing tools specific to the defensive action. Include in your plan the ability to quickly change methods, equipment, and number of team members based on the dynamics of the incident. Creating detailed plans based on NFPA 472 will organize your actions and improve life safety for your team. As a part of the planning sequence to limit exposures, your team also needs to establish clear defensive objectives.
To get up close, so what we'll do is we'll wait for the hazmat.
In other words, define what your goals are for stopping the spread of the hazardous material to maintain life safety for responders and the public.
Suppressed it so they can shelter in place. So Ken, if you'll take care of our supply line, Damon will...
A common type of incident would be a rail car releasing vapors near a roadway. Your defensive objective will be to suppress or disperse the vapors to protect a nearby residential area. You also need to account for any traffic that may endanger responders as you work the scene. As you identify these threats to life safety, communicate your defensive objectives with your team. A vehicle carrying hazardous material has been overturned in a crash with a pickup, and liquid is spilling directly onto the roadway. Your defensive objective may be to quickly dilute or remove it from the driving surface so it doesn't spread or ignite. Communicate your findings with your team and build your plan off of those findings. Again, this is a simple step, but making these objectives clear will better coordinate your efforts. A drum is leaking hazardous liquid near a stream.
If we can right that drum and keep it from leaking, we'll right it up so it doesn't leak. If we can't, take shovels with you and do some damming and diking.
Your defensive objective is to either prevent the spill from entering the water or keep it from traveling downstream. Identify, organize, and communicate the details of your objectives.
Small leak into the waterway. We got an overturned rail car.
Another incident could involve the spill of a large amount of liquid from an overturned rail car. Your defensive objective could be to prevent it from moving into areas where additional exposures may occur. Again, define your objectives and communicate these goals to your team. Other instances may involve a pipeline with an open valve releasing hazardous materials. Your defensive objective could be to locate and shut off the valve. Another example is when a large pool of petroleum has formed around leaking barrels. Your defensive objective will be to suppress its ignition potential. How you identify, define, and communicate defensive objectives is a crucial step in building your plan and how your team will respond to the incident.
See if we can contain the spill right here. All right.
Once you have identified your defensive objectives, you must carefully determine the level of risk before sending responders into action.
CECOM Engine 71 is on the scene of a rail tank car. We have a small vapor.
In hazmat incidents, the first step is to understand how the types of materials on scene can affect team members. If the materials you have identified are able to permeate PPE or undergo polymerization, this could present an unacceptable risk. You should not proceed with a rescue. The same is true if certain chemicals on scene present the risk of an explosion. When you verify the nature of the materials on scene with Chemtrec, the MSDS, and the Department of Transportation Emergency Response Guidebook, each of these factors should be accounted for. Physical hazards are also a concern in hazmat incidents. In a facility, specific types of physical hazards should be taken note of. If victims are trapped in confined spaces or under objects such as barrels, entangled in machinery, in a high-angle location, or in an unstable work area, you must perform a risk-benefit analysis before going in. When you are working out of doors, you also need to account for physical hazards. In an incident where retention holes need to be dug, hazards from utilities and underground pipes should be recognized before digging. Initiate a one-call to local utilities to find out if you're going to compound the hazards on scene. At a hazmat scene along a transportation route, heavy traffic and road conditions could influence scene safety. Make sure these hazards can be mitigated when developing your plans. When you are working near a waterway, assess physical hazards from the water itself, as well as the surrounding topography. Each of these factors could impact your risk-benefit analysis. Another risk to your team could be the environment itself. Weather conditions, such as precipitation and extreme heat or cold, can impact the effectiveness of your team members. especially when working in bulky hazmat PPE. Health risks from extreme weather can be a greater threat to responders than the hazardous materials themselves. Consider all of these factors when making a risk-benefit analysis on scene. After all hazards are identified and anticipated, you are ready to determine the defensive actions needed for the incident. Narrowing down your defensive options based on the physical and environmental nature of the incident, containers involved, and material hazards will streamline your planning sequence.
And for Fire Engine 92 is on scene.
In the case of a vapor release from a rail car, a select number of defensive options will best serve the needs of the incident. Vapor suppression or vapor dispersion will be your primary choices, as your objectives will be to knock the vapors down. This decision will influence how your team will proceed with the mitigation effort, the type of equipment you'll need for the job, and any plans for runoff containment. At the scene of a roadway incident, a spill is collecting. Absorption, dilution, or retention could be your best options. Knowing each option, given your team's resources, will help define the size and scope of your defensive activities.
Looks like 2 barrels on their side.
A waterway is being polluted by a hazardous material. Your most likely options are diking and damming. A large amount of material from a rail car is spreading quickly. Your best defensive option may be to dig retention holes. Several barrels are leaking petroleum, creating an extreme fire hazard. Your best option may be to apply a layer of firefighting foam to suppress it. As you survey and learn more about the incident, paring down your defensive options to those that are the most viable will guide your planning process. Now that your team has assessed your defensive options, you are ready to prepare for your chosen control technique. It is critical that you understand the purpose, equipment, and safety precautions for each method. Your team should be well practiced in each of these techniques before you receive a call to respond. At the scene where you have chosen to use absorption, you need to know that the purpose of absorptive materials is to keep liquids from spreading to other areas. Some commonly used absorbents are synthetic fibers, corn husks, clay kitty litter, or ground-up newspaper. An important precaution to remember is that the absorbent will become contaminated and may retain the hazards of the absorbed material. You may also choose to use a dilution technique. The purpose is to limit the material's ability for harm by adding water to it. You'll need hose lines and a water supply for this action. A major risk is that dangerous runoff can continue downstream and contaminate other sensitive areas. At the scene of a spill near a waterway, you may choose to employ diking or damming as a control technique. The purpose of diking and damming is to contain a spill on the ground or within a waterway. The equipment you'll need can include dirt, sand, or rocks. You will also need shovels and pipes to construct overflow and underflow dams. Secondary contamination is a risk you'll need to account for when using these techniques. The purpose of diversion is to direct a running spill away from a storm drain or waterway. Dirt, sand, absorbents, tarps, and hose lines are all capable of keeping spills away from drains. Diversion can be used for spills in water, where the hazardous material floats. Booms are commonly used for this purpose. One of the major safety precautions is to have a large enough diversion system for the amount of materials on scene. The purpose of retention is to catch large running spills. You'll need shovels or heavy equipment to dig holes big enough to contain the spill. Be aware of any utilities before you dig. Remote shutoff techniques are used to stop the flow of a product from an area away from the hot zone. One of the safety precautions you'll need to remember is to avoid getting into the hot zone to access the valve. You may need hand tools to assist in turning off a valve. The purpose of vapor dispersion is to prevent clouds of materials from affecting the population. Using apparatus and water sources to spray the cloud, responders can knock down the vapors relatively quickly. However, hazardous liquids such as anhydrous ammonia can create extremely dangerous runoff. Vapor suppression is used to control flammable materials in the air. Different types of firefighting foams are used specific to the type of release involved. A major safety precaution is to be aware that some foams are incompatible with certain materials and that the foam runoff must be contained. Also make sure that you have a sufficient stockpile of foam to maintain a layer over the spilled material.
What do you have, Kevin? We got a 2-vehicle MVA.
If your team decides to take defensive actions, you need to know how to use equipment, understand its purpose, and recognize all safety measures before you implement your response.
We stay uphill that point as best we can, okay? Our protective action should be good as they stand. What we probably need to worry about now is dispersing the material so it doesn't create a...
Defining your response objectives and understanding your defensive options are critical steps in planning for a hazmat incident. In this program, you have learned about determining how to limit exposures with available resources, the steps to determine defensive objectives, assessing risk to responders, identifying your defensive options, and how to choose the correct control techniques. Hazmat incidents require extensive and accurate planning to maintain life safety for responders and the public. Clearly stating your objectives and understanding your options are major steps in formulating a plan and protecting your community.